The question that I have is, could you tell us what determinacy and stability of a truss are? And we'll keep this typical truss on the side for reference. Each problem, such as this truss problem, has a certain number of unknowns associated with it, right? So let's call that as n sub u. So where are the unknowns for this truss problem? Well, it consists of two types. There are support reactions to be found, and here in this example we have three of them, right? So on the pin we have two force support reactions, and on this roller we have a vertical force support reaction, right? Let's denote that as little s. The second type contains the forces in the members of the truss. So the total number of them will be exactly equal to the number of the members of the truss. So let's denote that as little m. And here we have 13 of them. And therefore the total number of unknowns for a truss problem is m plus n, which in this example is 16. So we need some equations to solve for these unknowns, and let NE be the number of equilibrium equations that can be written down for the free body diagram of the truss. It turns out that the total number of equations that we can write down for a truss is exactly equal to 2 times j, where j is the number of joints in the truss. Remember what we did in the cable systems, right? We'll take each particle and write down 2 force equilibrium equations, right? A truss problem is very similar to that. So you take each joint and you can write down 2 equilibrium equations for each joint, and therefore the total number of equilibrium equations you can write down would be 2 times j, where j is the number of joints in the truss. The definition of determinacy is based on these two numbers, nu and ne. A truss is called statically determinate if nu equals ne, and is called statically indeterminate if nu is greater than ne. When nu is ne, we have the statically determinate trusses, and only thing we will need in order to solve for all the unknowns of the problem are the equilibrium equations. Going forward, this is the only type we will consider here. In the statically indeterminate problem, the number of unknowns are greater than number of equations, therefore we need some additional equations to solve for the unknowns. So we will not consider such problems here. Now let's discuss stability. It turns out a truss can be unstable for these reasons. It can be unstable if nu is less than ne. In other words, the number of unknowns of the problem is less than the number of equations available to us through equilibrium. A layman way of thinking about it is when nu is less than ne, you are not supporting it at sufficient number of points in sufficient number of directions in order to hold it stable. A truss is unstable if external reactions are parallel to each other, like shown in this picture. And this is fairly easy to understand based on this picture. For example, if I take this truss and push it sideways in the horizontal direction, there is no support reaction to stop it. It can keep sliding, right? And similarly, if the external reactions are concurrent, like shown in this picture, the truss is unstable. Why are these reactions concurrent? Well, you extend the line of action of each of these forces. They all meet at point A, right? Is there an easier way to understand why this truss is unstable? Yeah. If I take a moment at point A, the moment of the support reactions is 0, right? And therefore, the support reactions are not balancing the moment of the external forces. Since the magnitudes and the directions of the external forces can be anything, it can be arbitrary, right? The moment equation is going to be violated in most cases. Therefore, the truss is going to be unstable. Finally, a truss can be improperly constructed, which will lead to instability. Here's a simple example of that. We have a rectangular truss, and you can see even though nu and ne are equal to each other in this case, which I will let you check it out, if I push it sideways, the truss is going to collapse. So there's a way to construct a truss so that it will be stable. This is not one. In another video, we'll talk about how to construct a truss so that it will be stable.